Moving on, one of my favorite things, the climate and geography. We've talked so much about the sun driving all the processes in our atmosphere. The sun heats air, the air rises, cooler air replaces that air that has risen. And as that warmer air rises and the cooler air comes in underneath, that's going to create the winds that we see. So all wind is solar powered. And remember, the wind drives ocean currents, which are so important for our global climate. Distributing heat throughout the earth, taking warm air from the middle, the equatorial regions, pushing that warm air, that warm water north, which allows northern areas to have more crops, to have more rainfall, to have more land that life can live on. So this life we see really depends on the sun moving heat around the atmosphere, through the air and through the oceans. Remember, there is some energy coming from the Earth's core. And that energy we can see volcanoes, hydrothermal vents, hot springs, Yellowstone, and we have some of that stuff in California here. So the geography, rivers, lakes, streams, drives the weather. And what we'll get to, where you see mountains, where you see flat areas, where you see valleys, that will affect what kind of climate you have. So mountains, lakes, valleys, that impacts what kind of weather you might get, more or less rainfall. So let's get into some of that. We look at the world here. This is a nice comprehensive diagram showing all the different currents on the earth, the temperature of those currents. Like we see, for example, we talked before, our California current is cold, coming from Alaska. Not for long though, that water runs in these equatorial zones, warms up, gets pushed across the Pacific, winds back in Alaska, and then back down where it cools off, back down. And that happens globally. Interestingly, around the southern part of the world, around Antarctica, you basically just have a continuous cold current just circulating. But we can see in cooler areas, you often get, when the cooler area goes against the landmass, you often get drier desert type conditions. We'll talk more about that. We have that here in California. So the climate, the weather is closely tied to whether you have mountains near you. Like in LA, we have mountains right behind us. That helps moisture fall in mountains, and that moisture comes back down on rivers and streams. It's very helpful to us. Why people came here or stayed, we had the LA River. So a rain shadow. Very important to understand about rain shadows. You have moist air coming in off an ocean or another geographic area. As it rises, condensation occurs. because of that condensation, then you have the development of clouds and the rain. And that happens all along the slope. This is what we would see in California along the mountains behind us, Mount Baldy, San Gabriel's, and so forth. We see not a whole lot, but we see some precipitation that does sustain different chaparral type shrubs, bushes, small trees along the mountains here, the mountains off of the coast here in Southern California. Behind, when that air continues, it's very dry. And you probably have heard of the Mojave Desert, which is right over the mountains. You look wherever you're at, look over those mountains. About 20 miles past the peak, you're going to find extremely dry conditions in the Mojave Desert, all the way across Nevada. We've sucked all the moisture out of that air essentially as it has gone up the San Gabriel's and San Bernardinos and dropped the precipitation. We don't have that much precipitation because our air, our water is cold here. But there is some moisture in there. But these rain shadows, we'll look at several examples other than what I just talked about here in California. Here is the southern part of South America. You can see the Andes Mountains right here, very tall peaks up to I believe about 25,000 feet of elevation. I gotta look that up. They might be taller. They're not as tall as Everest, but they're pretty tall. Mid-20s, we'll say. But they're very tall along that western ridge of South America from that tectonic action, the subduction of the Pacific plate under the South America plate. And you'll see along here there is a warmer current, air current coming across the ocean, rising up above the Andes and depositing a whole bunch of rain right here. So on your paper, maybe, I don't know if you can draw a little thing of South America. So rain falling on that western slope. And then as the air continues across to the other side of South America, the eastern side, it's very dry. And we can see this area, this would be Argentina, pretty dry conditions. Now, if you go a little bit north, you'll see this area. This is the Atacama Desert. And that area is very dry because instead of being warm, these currents are cold. Let's see, yeah. Let's do that. And also, the air travel is not west to east, it's east to west. So the air is coming this way. You're having a rain shadow in reverse of what you see down below. So the moisture is falling here. Amazon River goes that way. I think it goes a little bit north. That's the Rio Plata, I think. So you have the rain shadow. You don't have very much moisture off that cold air, kind of like we have in California. You end up with a pretty serious desert. Here is a nice picture. I believe this is Hawaii, but extremely clear, where you have, let me go back, where you have warm, moist air. off the ocean. Going up over this hill, a lot of rain here and no rain over here, right when it gets over the top of that mountain. Really good rain shadow. Just couldn't be very clear. Now I want to show this because this is Washington State, where I grew up, and my hometown is right here. This is Yakima. And I grew up, you guessed it, in a place with very little rain, around 10 inches a year. However, we had lots of streams and rivers because the Cascade Mountains are over here, and look at that. Look at all that rainfall. Tons of rain. Even more than Seattle, right? Because Seattle is low, but here you have the Olympic mountain range and then the Cascades, and those are two places where the elevation goes up. That creates condensation, creates a lot of rainfall. But on the eastern side, we get all the rivers, so we get kind of the sunshine and then all the water to go along with it. And we'll see, here's a good diagram. This is showing California, but it could be Seattle. Like this could be right here, this could be Seattle right there. Although our Central Valley is a lot drier than Seattle. This could be the Olympics right here, the coast ranges that go up and down our California coast and the Sierra Nevada. So you do have moisture-laden air coming out of the Pacific, rising up over the coastal coastal ranges, raining right there. Then going down, descends, it's drier. As it moves across the valley, picks up moisture. As it ascends the mountains, get a lot of rain. So, and then on the other side of the Sierras, it gets pretty dry again. So the eastern Sierras are pretty dry. The western Sierras are a lot wetter. Okay, but this is, what we have in California, which is exactly almost what we just saw in Washington, and you could go up and down the coast of California to see that. This is kind of interesting. You probably heard of the Pineapple Expresses, the atmospheric rivers. This is a great example of this effect. When you have those atmospheric rivers, Pineapple Expresses are just extremely moisture-rich air coming off the Pacific. And you see when they cross these coast ranges, they just dump tons of water, that purple, light purple, and then they dry out, you see, as you go down in elevation, and then you go back up in elevation, the Sierras, you have tons more precipitation, snow, hopefully. Here's kind of revisiting that diagram I showed before. You can see it a little bit better, but this extremely dry area, the Atacama Desert, due to these really cold currents. You also have a lot of upwelling, so cold currents, and you got upwelling, which is bringing cold water from deep in the ocean up to the surface, creates a very, very rich marine environment, but creates very little rain for the coast. It's kind of counterintuitive to be right next to the ocean and be so dry, but it's because of that cold water. That cold water just doesn't create the evaporation that you see like in this other area. Right down beneath it, you can see, there's a lot of rain there. Well, that's because this current that comes across is warm. It brings a lot more moisture. But it's just a lot colder up north. Remember, this is the Atacama. I think it is the driest place on Earth. I think it rains every 5, 6, 7 years. You get a little bit of desert, a little bit of coastal fog, but that's about it. If we pop over to Africa, we see a very similar situation happening. This is the Namib Desert. guessed it, this is all from this very cold current that's coming from basically the water of Antarctica across the Namib Desert, and it just sucks the moisture out. In both places are similar. Like you look, this is about the equator in Africa, and this is about the equator. And if you look about 30 degrees south, about 35 degrees, 35 degrees, you tend to have these dry areas because they tend to have cold, dry air descending, because you have all that moisture-laden air coming up from the equator, and then clouds occur, condensation, the air dries out, cools down, and then descends, and that can create a lot of these deserts. You see the Namib Desert and the Atacama, they have the combined, they have that cold, dry air from the Hadley cells coming down. Hadley cells. Both of these are in effect. Hadley. And combining, just so you have really dry air. And that's what creates those deserts.